Hi guys, Godwin here. This is pretty unexpected. Kasi context, just someone messaged me. They were asking me if I had notes on AC analysis. And I said, what subject? And they said MEBASEE. And so, of course, I don't have any notes. I wasn't a writing guy back then. I was just listening to my profs back then. And, magre-review sana ako ngayon, but well, look where we are now. I'm gonna be teaching about AC components and how to analyze them using the complex plane and the imaginary units. Okay. So yeah. Before this, syempre, you guys have been introduced to DC circuits, of course. DC circuits, right? The ones with the batteries that look like this because they're AC, right? Positive, negative, and the only components that you've had so far are resistors. I mean, merong voltage dependent, current dependent sources, blah blah blah, and also current sources. But yeah. Besides that, resistors lang yung merong ang tawag dito ata is passive components, I think. And so of course that's for the realm of DC. DC is where everything is stable, everything is normal, and you always have a constant stream of current. What if we go on over to kung ano yung ginagamit ngayon, which is AC. AC means alternating current, and that means that your signals aren't just direct. There isn't just a constant stream of current or something like that. There isn't just a constant stream of voltage. There's an alternating, there's a sinusoidal uh, stream of voltage. So, in these types of circuits, meron tayong makukuhang dalawang bagong component along with a change in our sources. So, of course, meron tayo ditong voltage sources, but now they're drawn like this, and then blah blah blah. Those are the terminals, and ayan, positive, negative. So, dati kasi the batteries like this, they just supplied voltage like this. Sabihin natin, whoa. Sabihin natin this is time and this is voltage. They just supplied voltage in a constant stream. Constant stream. There you go. Sabihin natin that's like 5 volts. In this case naman, in ACs and AC voltage sources, your sources supply you voltage or current or something like that in in a sine wave, right? So they're not constant. And meron tayong ibibigay na mga equations regarding that. But for now, let's go on to our passive components. Besides the resistor, we need to make better resistor. There you go. Besides the resistor, we now have two new things, which are our inductors, which are drawn like clouds, I guess, and capacitors. You can draw capacitors like this, pero if you draw capacitors like this, that means that this flat side is positive and this curved side is negative. If you draw it like this, hold on. If you draw it like this, there's no polarity, then there's no problem there. Pero I'll just draw a better version. There you go. So now we have three passive components: the resistor, the inductor. You're gonna know why it's called L later, and the capacitor. And so okay, next, how are we going to go about solving or analyzing these kinds of circuits? Right, it's AC. Um, may mga na-devise ang mga electrical engineer. I don't know how they did this, but this is very clever. They used the complex plane. If you remember what complex numbers are, their complex numbers are like this, right? Z is equal to A plus B I. So what's I? Of course, I, our magic number, that is I is a number such that I squared is going to meet it's going to be -1. So normally hindi siya makikita in daily life, right? You don't have the solution to you don't have the solution to x squared plus 1 is equal to 0. It doesn't exist, right? So in this case, I is the solution for that as well as negative I. So ayan. Um however in when you're using it in the terms of electrical engineers, you're not gonna use I, you're gonna use J, right? Ewan ko rin kung bakit, but I mean, oh well, okay, let's just respect that, I guess. So ayan, how is the complex plane constructed? So you have your x-axis here, which is going to be the set of all real numbers, RE. And so you have plus 1, plus 2, plus 3, blah, 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 minus 1, minus 2, so on and so forth. And so what's on the y-axis? On the y-axis, we have the imaginary numbers. We have I, we have 2i. On the other hand, we have minus I, minus 2i, so on and so forth. All right, so how are we going to plot this? What do you call this? This is called a phasor pala. This is called a phasor. This Z is called a phasor. It's gonna be clear why. Sabihin natin, let's make our let's make our Z more more noticeable. Let's try 2 plus 2i. So ganyan. How are we going to plot that? So let's look for 2 in the real number line. That's 2. And we're going to look for 2i in the imaginary number line. Kung ano yung intersection nila, let's say here, you just draw a line like this from the origin. Oops. A line like this from the origin to the intersection point. And that's what you call your phasor. So, okay. So ayan, it looks like a vector, right? So in a sense, it is a vector. It is a vector, but it's more used in the complex plane, ganun. And so this is actually called your rectangular version of your phasor. Rectangular siya. It's called rectangular because this configuration of the real and imaginary line, it's rectangular as in you remember Cartesian coordinates, right? You look for number 2 and you look for 2i and then you look at their intersection, right? And everything looks like rectangles, right? There's a grid line there. You can translate this into what we call a polar coordinate by means of tingnan natin ha. Should we pick a better example? Okay, yeah, let's pick a better example. Okay. Hold on. Let me just do this. Let's do z is equal to 3 plus 4i. Right? That should be good. Okay. Ang nga pala, another note when you're writing this in terms of engineering, electrical engineering, you don't write 4J, you write J4. I mean, I guess profs accept 4J, pero you see that often in your textbooks, in their lessons, so might as well stick with it as well. All right, so balik tayo sa complex plane. Let's just estimate where 3 plus 4, J4, sorry. 3 plus J4, where that phasor is. So 3, 1, 2, 3, maybe like there, 1, 2, 3, 4, maybe there, and then you just go like this, right? So this is our rectangular version. How are we going to get our polar version? So our polar version here, ang gagawin natin, titingnan natin kung ano yung radius ng circle, kung nasaan yung the head of the phasor. So of course, where is this head going to be? Of course, this just measures the distance from the origin to the diba? To the head of the phasor. So, what is there to do? Of course, you see that there is a right angle, and of course you apply excuse me. Of course you apply Pythagoras' theorem. 3 and then 4. Of course, this makes sense that this should be 5, right? Pero if you want to just be sure, let's say x is equal to square root of 3 to the 4, no. 3 squared plus 4 squared, that's 9, that's 16. And if you further it, and if you simplify it further, you get square root of 25, which is 5. All right? And so, yun yung una nating coordinate actually. And so you write down here 5. And then you write down an angle sign. And then, of course, that should give you a clue as to what the next coordinate is. The next coordinate is going to be the angle from the positive x-axis to the line itself. So that's theta. Yeah, basta angle siya, right? And so how are we going to get that angle? Of course, from SOHCAHTOA, the best way to do this is to say that we know that the tangent of theta here in this sense is opposite over adjacent, right? So 4 over 3. And so if we apply arctangent on both sides, we're going to have theta is the arctangent of 4 over 3. Then let me just plug that into my calculator. Actually, guys, ang convention dito is degrees. So just saying where is that? Arctangent of 4 over 3, you're going to get 53.13012. Right, 53.130.102. And you might ask, why is it so accurate? If ano kasi, I originally thought this topic was for MEMACHI, or the, you call this, the subject after this, subject after MEBASEE, which has to do with AC DC machineries. And the professor who taught us that subject, Elmer, really feels weird saying his name without a sir. He said to be really accurate, as in 6 degrees, 6 decimal point accurate. Para sure tayo, di ba? Because like a tiny change in this a tiny change in this, what do you call this? In this angle, or also in the in the magnitude of this distance, would change this very dramatically. And so yun, just wanted to be sure, if you guys are going to do like problem sets of this, just make sure that you're really accurate, right? This is like one of the only times that you have to be really accurate. But anyway, eto, just to recap, rectangular is in the form of A, that's your real part, plus B, that's your imaginary part, and then an I, or sorry, A plus, no, JB. All right? In the polar naman, you have your radius. What's your radius? And then angle, your angle, of course, your theta. So some professors like to write their angle on the angle sign. It doesn't matter naman. So ayun. Um why do I need to tell you this? Because we are going to use imaginary units nga in our AC analysis. So, dati ang Ohm's law natin is just V equals IR. Now things have changed. It has now become V is equal to IZ. You might wonder, what's this weird like typeface? This is actually notation for vectors, right? If I wanted to, I should have made that bold. Yan, that's the notation for vectors, right? So, um, why have I done this? Why is voltage and current a vector? Because those guys are going to be your phasors. Yun yung mga ginagawa natin kanina, right? So, V, of course, that's your voltage. That's sabi ko kanina, ang graph niya, it's going to give you something like a sine wave, right? But how do you call this? Most of the times your supply voltage is going to be given as syempre a function of time with this kind of format. VM, which stands for maximum voltage, and then cosine tayo ha, cosine of omega t plus phi. What does this mean? Of course, VM, that's your amplitude. That's the highest value that your voltage can go, right? Of course, your omega, that's the frequency, how frequent the cycles change per second, right? And then your phase angle, this is phi. This is responsible for telling the function where it should land at time equals 0. So may ibang ganyan yung may ibang ganyan yung graph. So no problem. May ibang ganyan yung graph, may ibang ganyan yung graph that just has different phase angles. And so paano to gawing phasor, right? And so ang turo sa amin is that if ever you want this to become a phasor, let's just write down the bold Vs. You're going to have to write this down in polar. Vm, that's your radius. And then your angle, and then your phase angle. That's how you write your voltage down in in phasor form, in polar form. And so that's just the same with current. Wala namang pinagbagong marami. IST, and then this is gonna be IM, and then this becomes IS, and then this becomes IM as well. Yeah. Okay. So now the only thing I've ignored talking about is this Z. So it replaced R here because Z is now it's now also a complex number, but it's not a phasor. It's just a number, right? This Z is called impedance. Impedance. So if you have earphones, you might see this at the specs of your earphones, right? Impedance here. Oops. Impedance here means R, right? That's your resistance. That becomes the real part of your impedance plus this thing called X. Actually, JX. Ayan. This thing called X, which is the reactance. Reactance. Right? So, paano naman to? How are we going to do this? So, yung dalawang bagong passive components natin, the inductors and the capacitors, they have different kinds of reactance. All right? So, I'll be going there now. All right. I'll be going there now. Right, sabihin natin meron tayong binigay na voltage, supply voltage na function. Vs as a function of time, that's gonna be equal to, I'll just set this to be my example, 120 cosine 60t. Ayan. All right. So, let's just identify what our Vm, our, what do you call this? Let's identify our Vm, our omega, and then our phi. All right, so Vm, of course, here is 120, right? Our omega here, kung ano yung nakadikit sa t, that's gonna be 60. And then our phi, wala naman tayong phi. This 60t is just like 60t plus 0. So our phi is 0. That's no problem. So if you want to rewrite this in phasor form, your Vs, that's just going to be 120 angle 0 degrees. Excuse me. Now, eto, simula tayo sa conductors tuloy. Inductors. So inductors, I'll just give a brief preview of like what inductors do. They store energy using magnetic fields, right? Okay, I don't want to go further in that. I just want to teach how the computations work. So, inductors, they have their own unit that's called inductance. And inductance, I don't know why, that is denoted with an L, right? So yun nga yung L kanina. And so they're going to have a reactance. Inductive reactance ang tawag sa XL, X sub L. That's just going to be J. That's your imaginary unit. Your omega, which is the frequency of your supply voltage, and then your L, kung ano yung inductance. I forgot, the inductance is measured in henries, H for henries. And so usually kapag binigyan kayo ng problem, you'll see something like 32 millihenries, something like that. Now you know how to turn that into your reactance. And of course, reactance has a unit of ohms. See, at least familiar yung ohms, diba? And so for the next one, we have capacitors. So capacitors, instead of storing energy inside magnetic fields, you're storing your energy in electric fields. You may have discussed this in your BASFIS, the dielectric effect. So it stores energy like that. So syempre meron din silang sarili nilang unit, which is capacitance. This makes more sense because it's denoted by capacitance. Yeah, it's denoted by the letter C, right? And it's and its units are farads, F, big F. So it's cap- capacitive reactance. It's now going to be I, sorry, not I, 1 over J W C. And so what do you notice? Okay, let's just have a brief tangent on that. Of course, tell me what's I to the 1. That's I. Tell me what's I to the 2. That's minus 1. Yun yung definition niya, right? I to the 3 is just like I squared times I. So this is just going to be negative 1 times I is going to be negative I. And then I4 is just like I squared squared, right? So what's negative 1 squared? It's going to be positive 1. So let's just backtrack. What's 1 over I? 1 over I, since the I is in the it's in the denominator, you might as well say it's going to be I to the minus 1. Or meron pang pwede kang gawin, which is, you know what 1 is? 1 is I to the 4th. So I to the 4th over I, that gives you I cubed, which is minus I. So 1 over I is equal to negative I. All right, why did I give you that off tangent? Because I just want to I just want to drill in your minds that inductance here will always be positive, and your inductive reactance here is always going to be positive. And since meron tayong 1 over J here, this capacitive reactance is always going to be negative when you what do you call this? When you compute for the reactance, right? All right, so what better way for us to learn together, because I forgot how these things work as well, through an example I just made like 20 minutes earlier. Hold on. Okay, I'll just draw it. Ito yung same ito yung same supply voltage niya. All right, I have a supply voltage here. Alam na natin kung ano yung function niya, so there's no problem. I have here an inductor, I think. Hold on. Wait. All right. We have here an inductor. Yes. It has 50 millihertz tuloy, millihenries. We have a branch here. I don't want to draw it like that. All right. We have a branch here with a 15 millifarad capacitor, and then a 20 ohm resistor. And then finally, we have another branch. Whoa, what? Why does that keep happening? We have a resistor here, which is 10 ohms. And then we have an inductor here with an inductance of 30 millihenry. And so, ang gusto ko lang itanong is, what's the total impedance of the whole circuit? And we already solved what the phasor form of the voltage is. So I just want to know what the phasor form of the current is, as well as try na rin natin. Let's see if we can get the function of the current just like this, right? All right. So let's start off with trying to get all of the reactances of each component so that we can rewrite these units, right? So let's start off with this guy, the 50 millihenry. Ang sabi kanina is XL is equal to J omega L. So that's just going to be J times our omega is 60 and our L is 50 millihenries. So that's 0.050. Right? So let me just 60 times 0.05. That's going to give you, of course, right? That's going to give you 3. J3. So we can remove that. We can replace it with J3 ohms so that hindi na natin kailangan mag-alala pa. Okay? All right, next one. Let's just do the other inductor now. Whoa. Let's just do the other inductor now. It's going to be J times 60 as well times 30 millihenry. So 0.030. 0.03. That's 1.8. J 1.8. Whoa. J 1.8. All right. J 1.8. Okay. So the resistors don't need any like conversion. They're already in ohms, right? So ang kulang na lang natin is the capacitor here. So this is where a lot of people, including me, I remember that time when I got confused. I just wrote down, kasi alam ko na before na uh, capacitive reactance was going to be a negative. So I just wrote down minus JW, sorry, not W, omega C. This is wrong because the original one is just 1 over J omega C, which if you want to rewrite it with negative J is going to be negative J over omega C. So big wrong. Do not do that. And so let's just follow our let's just follow our formula for now. And oh right, okay. So for a lot of you guys who have, of course, I think every one of us needs a calculator. Meron yan most probably na na imaginary unit mode, right? For I'm using a classes right now, and if you want to access this complex mode, you just do menu and then number 2, and it should take you directly to yung complex mode. And there should be a button here that's going to be rewired into making you, what do you call this? To making you press yung I. Ayun. So, yeah, there are also other functions here such as yun nga ang sinabi natin kanina, you can convert the rectangular to a polar. That's also possible here. You can also do the vice versa. You can get a conjugate of something. Right. Okay. You can also get the argument. Argument means kukunin mo lang kung ano yung angle nila. And then you get the real part, imaginary part. Most of it is in modern calculators that we have. Ewan ko lang kung magagamit natin yan sa boards, pero yeah, let's not worry about the future for now. Let's just worry about this. Okay. Saan na tayo? Okay, 1 over J, our omega is 60, and then our capacitance is 0.015. Right? Alright, so 1 over I times 60 times 0.015. That should give you minus 10 over 9i. Alright, so for me, my personal preference lang, I just like to keep it how do you say this? I like to keep it in fraction form para hindi ko na kailangan isulat yung decimal, because I know the decimal for this is gonna be really long, like minus 1.111111. I don't want to keep writing that. So just gonna turn this to electrical engineering minus J 10 over 9. All right. Minus J 10 over 9. Let's just make that clearer. 10 over 9. And then now we can start applying the rules, all of which are applicable for AC circuits pala. Let me just make that clear. So not only is combining series, not only is combining parallel, that's applicable for AC components. Applicable din ang loop tuloy. Mesh analysis, nodal analysis, that also works. Superposition, although isa lang naman yung source natin dito. Thevenins, Nortons, that always works, right? Why delta, that especially works because that's going to be a major topic in MEBASEE AC/DC machineries. But anyway, let's just try to combine this now. Syempre yung magagawa natin dito, i-combine lang natin to, right? Since these resistors are real and these guys are imaginary. Excuse me. The symbol that we're gonna use can't be just a resistor or a capacitor or an inductor. It just has to be just a box, a box like that. And then another box. And then this box has an impedance of, this is 20 minus J 10 over 9 ohms, right? You get it. You just add these guys together. And then syempre, same with this one, 10 plus J 1.8 ohms, right? Okay. And then this one is J3 ohms. And so we're going to combine these guys. And so what I like to do when two resistors are in parallel, I just do product over sum. So sabihin natin we have an impedance pala, an impedance of Z1 in parallel with Z2. I just say that their parallel resistance is Z1 Z2 over Z1 plus Z2, right? And so let's just try that out. 20 minus J 10 over 9 times 10 plus J 1.8, excuse me, over what's their sum. So 20 plus 10, of course, that's 30. And then 1.8 minus 10 over 9, I'm just gonna write that down as is, minus 1.8. Forgot to put the J. Hindi kasi ako sanay mag-J. I used to go scot-free by just writing I before. Pero ewan ko, I just want to get on with the rules now. 1.8 minus 10 over 9. Let me just enter that. 20 minus 10i. Not that. 10i over 9. 10 plus 1.8j. I. All over 30 plus I times 1.8 minus 10 over 9. That should give me, all right. That should give me, I'll just write this down here. ZT is going to be 748 pala. 748,825. That's our real portion. And you can just scroll to the right. Plus 0.06746,566. But round up, you get 674,657. And then, I forgot the J. And this is rectangular. This is rectangular, but you can make it to, you can make it to polar. Ang gagawin mo nga lang, same as always, your R, diba this is your A, right? Your A is your real part. Your A is your real part and your B is your imaginary part. The formula for this is, let's just draw the complex plane again. Ayan. So, ang mangyayari, this is your A and this is your B, right? So, your R is going to be square root of A squared plus B squared. You can just do that. And then your theta here is just going to be arctangent of B over A. Right? If you don't want to do that, syempre meron ding option ang mga calculator for just, converting this into polar form. So I'm just gonna do that now, and that should give me, and this should make sense too. That should give me 6.782463, and then angle 5.708694 degrees. Okay, so just a gut check to see if everything looks correct. Yung 6.78 looks a bit like 6.78 here. That's why, this is why, why is that pala? yan. Why is that? It's because your J is relatively small. It's less than 1 J1. So, syempre, hindi siya makaka-affect ng malaki dun sa radius mo, right? And so, that should also be true for our angle. The closer the angle is to 0, the more real, quote unquote, it should be, right? The bigger the real value is, the smaller the angle, right? Consequently, if your angle is just 90, it's closer to 90 degrees, mas malaki na dapat yung imaginary mo. All right? So that's our ZT. Right? That's our total impedance. And so how are we going to get yung, oh wait, no, it's not ZT. No, it's not. We forgot to add the J3. Okay, this should be easy. Let me just, you just add J3, right? Since it's in series with this parallel connection. So, ang papalitan mo lang is the 0, right? And this should change. This should entirely change. Instead of 0.67, it should now be 3.67. A good thing I spotted that. That would have been really embarrassing. Let's turn that back into rectangular form and let's add 3i. And so yeah, ayan yung ano niya, yung rectangular form niya, 6.748825 and then 3.674657. If we're going to get that back into polar form, you're gonna have 7.684383, right? Okay. And then angle 567. Jesus. 76 degrees. Okay. And also one more thing, if you notice, if it's closer to 45 degrees, then that means the coefficients of your real and imaginary parts should be the same, right? Should be near one another kapag malapit siya sa 45 degrees. Anyway, ngayon, now we have the real total impedance with us. And how are we going to get our current as a phasor and as a function? All right, how are we going to get that? Of course, we just employ V equals I Z, right? So your I should be V, it's really hard doing this, over Z. And so pwede mo namang gawin na 120 angle 0 all over this thing. Put that there. That should give you something like, I'm just gonna store this total impedance value. Alam ko na 120 angle 0, since it's angle 0, it's all real. So I don't need to put angle 0. It's just gonna waste my time. So I'm just gonna put 120 over what we got kanina, the answer. It's gonna give us, all right, it's gonna give us this rectangular value, 13.714861 minus J 746,758.2. Right? So that's our current as a rectangular form, right? Rectangular form phasor. If you want to make it into, what do you call this? Into polar, we just, you can search for yung manuals for your calculators regarding complex operations. Online naman, I think it's readily available. And then let's just make it into polar. That should give us 15.616087 and then angle of minus 28.567776 degrees. And so what do we notice here? We notice that this is just a negative version of the angle. O nga pala, huwag kayo matatakot if it's negative. There's no problem. Matakot lang kayo if it's gonna be like if it's over 360 or lower than minus 360. That's a problem. Okay, anyway. So yeah. We noticed that this angle here is just the complete opposite of this ZT. Why is that? That's because your what do you call this? Your voltage here has 0 phase angle, right? And ang operation dyan is whatever is on top, you subtract it with the phase angle of the bottom. So 0 minus 28 point blah blah blah, that should give you your minus 28. Although I'm not sure if that's the case for everything. I forgot what the operation here is because I've become reliant on my calculator for these kinds of things. Pero if I'm pushed naman to like do it manually, I mean I could. I guess it's gonna be pretty long though. Pero yun. What do we want to do with this now? Diba sabi natin kanina we wanted to make this into a function, right? Like is as a function of time. So of course, we're just gonna we know what the I am here. We know what I am here already is. So it's just going to be 15.616087 cosine of, syempre kailangan same lang yung ano nila, yung frequency nila, 60t plus, sorry, minus pala, minus 28.567776 degrees. And that should be your, that should be your current function, right? And so ayun, uh, just to recap, all of the things you've learned before: mesh, nodal, superposition, the source transform works as well here, and Thevenin and Norton. If you haven't watched those, you can watch them in the YouTube channel for MES. MES YouTube channel. And yeah, those all work here for AC components, albeit mas mahaba lang just because they have we now have the imaginary unit, but besides that, it should work fine, right? And so ayun nga, same lang mechanics nung ano, we just have a new imaginary unit, but there's no problem because our calculators can handle that naman. So yeah, that's my recap for AC components and imaginary units. So if I may have missed something, you can just comment on this video para alam natin kung pwede akong gumawa ng like response video or like habol video for like extra ideas or concepts that I may have missed. And ayun, I hope you guys, you second years have a good time with MEBASEE. It's one of my favorite subjects. Kind of sucks that you guys have to do it online. But yeah, ayun. Don't forget to keep learning.